Okay, welcome to the update for Ansys Fluent 2021 R2. As always, there's lots to get through, so let's get started. And the first topic we're going to look at on this video is the user experience. So this is something of relevance to all of our users out there. This first thing that I want to show you is really quite important. There are now two ways of deciding exactly what's set in a Fluent session. So when you're under the run command, you can list modified settings and you'll get a panel like this, which is down on the bar at the bottom. And essentially what that gives you is a record of all settings that have changed from the default value. So this records for you boundary conditions, models, expressions you've put in, etc. The only thing that won't be there is if you do any TUI commands that are not available in the GUI, and those won't be recorded. There's a second option under that drop-down, which allows you to write a file which gives a really comprehensive list of all that's been set. So in that case, it's not relative to the defaults, but it's telling you exactly what models are set, what boundary conditions are set, etc. And that's going to provide you with a very good way of deciding what you've got. If you want to compare a couple of solutions or setups, you can write this out to a text file and then use a compare tool to compare the settings. Work has continued on the embedding of windows. So recall that we can have monitor windows in the same frame here as we've got a solution variable that's updating. So the key difference here now is that once you've set something up, this layout can be stored to the case file. You can also control exactly what's recorded to the case file in that by changing your preferences. Reports definitions have been made a little easier to use. So one of the key changes is that you now, when you create a report, it automatically creates a report file and a report plot. And there's an option here that if you're using averaging, you can retain all the data so that you can go back and replot with different averages. So that again just implies supplies a little more usability. Basic color map has changed. So if you recall in previous versions, depending on whether you were looking at the front or the back of the model, you could have a nice looking plot and then it became dark because the camera hadn't moved and the lights. Now there's no distinction. So that's a nice fix. There are more backgrounds here. You can change between a classic color set, which is what you're used to having, and one that's much lighter colors called pastel, and you can change that in your preferences. Also, the realistic rendering to be able to have metallic and glass finishes, etc., as you can see on the right-hand side here, which was in post, is now available in Fluent. The graphic states can now be recorded. So what this means is that once you've set up a set of options, like where you want the legend, how you want it created, whether you want the logo, whether you want the axes, how you want this oriented on the screen, you can save all that to a state. And then when you come to display things, you can choose which state that references, and it will automatically revert to the state. And those saved states can be exported to files and then reused. When you have a probe now, the probe technology has been improved. So if we click at a probe point here on the left, you can see that there are multiple things displayed, and it will tell you that on this plane symmetry here, that you're at a certain location on the mesh, that the contour is giving you one value, and the velocity vector here is colored by something else and gives you the value. Other enhancements to post-processing. Now, when you create an expression that resolves to a field, you can use that in the option for doing sampling. And so that can be used directly. There are more functions for fluxes, particularly those around mass, heat transfer, radiation, etc., so that you're going to be able to use those directly to look at balances. And you've got an option now to have multiple cumulative force plots. There's been improvement to the way the graphics handles large cases. So when you have a very large case with lots of faces and zones, it can become slow to move on the screen. So what you can do now is once you start moving, the detail will get reduced and then will get redrawn once you stop. And there are some really big reductions in time to do things here. And you can choose exactly how that's controlled via, again, something in the preferences in the graphics panel. There's a way to rename zones in a batch mode. So that's going to allow you to identify regions much easier and is a much quicker way of doing it. Simulation reports continue to improve. So there's more flexibility now. If you want to move things around in the report, you literally pick them up and drag them around. You can have improved tables now with links in it. And there's a solution status option, which tells you how many iterations were done and what the state of the residuals were relative to the convergence criterion. So again, more flexibility. If you haven't tried simulation reports, I would urge you to do so. It's a really nice way of putting out whatever you want from a simulation, and it's completely flexible as to what you include in that report. So that's the end of the section on usability. Right, meshing workflows. So this is for the fluent meshing. And again, there's been a number of enhancements we looked through. One of the key ones in terms of usability is the fact you can now have a dockable window so that when you have to set options for any of these tree items, you've got a full window there. You can actually collapse that window when you're not using it, and it'll appear over on the left-hand side here. And then you can reopen it. So you still retain a nice viewport here that you can see, but when you've got data to change or enter, it's much easier to do. A few additional changes to the watertight meshing workflow. We've been able to do extrusions for a while to extrude mesh, so we can put a piece of pipe on here, but those extrusions have had to be planar. You can now extrude, and then you can extrude mesh off a surface. So it could be to create an annular pipe here, or it could be to pull a section off there, for example. So you've got more choices there. You can import a body of influence now. So that might come not from the CAD that you've read in, but from another CAD file or a mesh file. So once you've got your base model read in, there's now an option to read in one or more bodies of influence. Periodic boundary setup has been changed. Previously, you could only do that after you had a surface mesh. Now you can actually do it before you create a surface mesh, so that it will pick one side, mesh that, and then copy that mesh onto the other side of the periodic. For those with large jobs that they need to reuse, you can read and write prism layer control files. There's also been more flexibility in patterning. So as well as doing linear patterns, these can now be used treated in a more complex way. So you can take the mesh of an object here, copy that into a zigzag pattern, and then linearly copy that zigzag to make that stack. Or you can translate and rotate cells here. Also in the watertight meshing, you can now merge zones. So there's a new option that will allow you to go in and do merging so that you've got much more control over the zones, so that when the mesh comes into Fluent, you've got the zones grouped together that you want for setting up physics. In the fault-tolerant meshing, the emphasis has been on speeding up things. So there's parallel generation of continuous prism layers. There's reuse of size fields to save it multiply calculating them. There's improved wrapping. All that is leading to reduced times. And there's now parallel polyhedral volume meshing supported. There's improvements to the CAD and part management. There's transform operations that you can do to help you move things around. There's an option to create your porous regions from a text file. And there's the ability to go in and auto assign zone types to the mesh. So that's the update on meshing for this release. Let's now look at a variety of solver and HPC enhancements. Again, these are pretty wide and should apply to most of our users will find something of benefit here. So as you'll recall, a lot's been done with mesh adaptation over the last few releases, streamlining the workflow, adding some generic setups for multi-phase. Well, that work has continued. And now there's 2 more sets of automated setups. So those for doing finite rate chemistry or flamelet generated combustion modeling, and also for high speed flow. So what that means is that you can just toggle to the predefined criteria, switch them on, and you won't have to do any other setup. The Puma-based anisotropic mesh adaptation is there now, and particularly that can be used for splitting prism cells. So for those who like to make relatively few prism cells to get a good quality mesh, and then go and use these tools to split, that's going to be there now in a nice simple interface. And just looking back at those predefined meshing refinements, you can see here some examples from combustion. You've got a really nice example on the far right of a combustor and being able to adapt to the flame. On the center here, you've got examples of ignition. So what's happening that one burner is ignited, and then you're looking to see at what time and how the adjacent burners light. You can see that's been captured really well. But most importantly, going with this meshing process, this has been reduced, the simulation, from 3 weeks to 3 days. So that's really by just being able to have adaptation move with the flame front. For the pressure-based solver, the Reed-Chow algorithm that helps you get, it's used to get velocities at cell boundaries in a consistent way. There's a couple of versions of it. One that works best for compressible flow and acoustics, another which works best for incompressible flow. Now, there's a simple toggle button here to choose between them, but also a nice option for auto select. And that will look at the setup of your calculation and pick the most appropriate for the simulation type you're doing. For the pressure-based solver, there have been some improvements in the adaptive time stepping to go with the adaptive meshing. There's also been work on the local scaled residuals, trying to make these residuals as meaningful as possible and get them up to the standard in CFX. So you can now set to always have those residuals as locally scaled in the preferences. And this is an ongoing task. When you load an old file with these, you will also get offered the option to switch to a new scaling for the mass residual, and that will bring it much more in line with what you expected. Overset meshing knows its compatibility with NETA, and improvements for intersection with prismatic layers. The whole aim of this work is to make the use of overset meshing much simpler and faster. There's now a gap model. So when you've got a moving object and there's a possibility that that object closes the flow off, there were a variety of ways to do it before, but now there's a new gap model that's consistent with the variety of moving and dynamic meshes that we've got, and it has significant advantages compared to the old contact detection method. Improvements in remeshing. So we've been doing a lot of work on this over the last few releases, and as you recall, it's been simplified a lot before. There's now even greater simplification, so that the initial mesh is now used to control the remeshing, and when you've got moving objects, those sizing fields are moving with the objects, and that was apparent in the videos you've just seen. So this is going to give you much improved remeshing. When you've got a moving boundary, now you can get the moving mesh courant number on it. So that was a previously released for Prof, but it's now available for other types of simulations. There are also improvements for when you have non-overlapping meshes and you need to introduce there some connections between them. There's much cleaner ways of doing that. There's ways of seeing what the connections are much more easily here. So that again is another nice usability change. So we're also making that process faster. So when you've got a lot of mesh interfaces to make, then that's being done much faster. And there's improved gradients at these interfaces. So not only will you get continuity of the variable across there, but hopefully you'll get much smoother gradients now. Sliding mesh performance has been improved for a whole range of different test cases. There were some memory leaks as well in the past that have now been eliminated. A couple of architecture issues or improvements. So the Slurm system for job submission is now fully supported. On Windows, the MPI has been upgraded to 2019 as a default. Now, that has one key improvement that is particularly relevant during these COVID times. It's resolved issues with Fluent crashing the instant a VPN network drops out. So prior to this, the job would just instantly crash. Now there will be a sufficient time for it to reconnect and continue. Also, for this MPI, certain chipsets are just going to give you improved performance. And I've got evidence from some users that they just get 8% speed up with this, with none of the other new features in the code. Again, for the adjoints, there's been a lot of improvement to speed and reduction in memory use. So that is particularly useful. So those are the general things. We're now going to start looking at some of the individually specific models here now. So let's move on with that job. Let's start with combusting and reacting flows. So we know this is always a big area of development at Ansys Fluent. So let's have a look at what's new in this release. So there's a new species post-processing quantity, which is now a component mass concentration. And that can be at the mixture level or the species level, so that when you need to post-process, you've got more flexibility in how you do that. For hydrogen combustion, if you're using FGM with the SBS approach, you might want to be looking at hydrogen or blended fuels. So you can now have a weighted progress variable, one that's dealing with the hydrocarbon part and the other that's dealing with the hydrogen part of it. There's also improved laminar speed calculations in Fluent. And this is all coming about because we've got the integration of Chemkin within Fluent. We've got ability now to look at unstrained flames, was always there, but now we can start looking at things close to blow off using flamelets again. So if you're interested in this, have a look. There's been a lot of validation done here, and we can provide you with more data. Perforated walls were introduced a few releases back. The idea here is that if you've got, say, a plate with many holes in it, you can either make that geometry explicitly and calculate the jets coming through, or you can treat that as a wall and use a submodel that treats the flows coming through. Now, the big advantage of the latter is that if you're trying to optimize that plate and look at different hole positionings, etc., the perforated wall model just requires you to make some changes in the setup. You don't go back and do any remeshing. So it's a much, much quicker way of doing things. This has been used a lot in combustors, but now it's also available for use in fluidized beds. And the effective discharge coefficient from these holes can actually now be changed as well. So you can use your own UDF as opposed to using one of the inbuilt correlations. Okay, that's it for combustion and reacting flow. On the turbomachinery front, there's been just really one major change for this release, and that is the non-equilibrium wet steam model. So this used to have an equation of state that could lead to unphysical behavior. You could have the total pressure increasing when you weren't doing any work on the fluid. And in fact, you should have a drop in pressure. So there's been a lot of test cases done now, and you can see that here, compared with experiment, also compared with CFX, Fluent now has the correct behavior. And this model at the same time has been made compatible with the turbo interfaces. So frozen rotor, mixing plane, transient rotor stator. So you can do in Fluent with this model now what you could do in CFX. And as you can see on the right-hand side, you're also going to get the same answer. So if you're doing wet steam calculations, there's no reason not to move across into Fluent now.